Hello everyone, welcome to our second day of the Rcgi in Review 2020, 5 years of gas innovation. I am Gustavo Assi, and it's my pleasure to welcome you today for this meeting where we're going to be reviewing the achievements and the challenges of the first 5 years of the Rcgi. The Rcgi is the Research Center for Gas Innovation hosted at the University of São Paulo and is sponsored by Shell and FAPESP. And I will present to you in a few minutes, very briefly, the idea of the Rcgi, especially if you're coming for the first time and you're not completely informed about the Rcgi. If you're returning from yesterday, welcome back. But if this is your first time watching the Rcgi in review, it's good to know that we started this event yesterday. So there's another video in our live stream and also in our YouTube channel. So you may want to go back and watch what we have discussed yesterday, because today it's only half of the Rcgi that will be reviewed, because the first half was reviewed yesterday. Let me just give some introduction to our program today, but also about the Rcgi. And if you're not aware of the Rcgi, I'll give you a very brief description. The Rcgi is, as I said, the Research Center for Gas Innovation, which was founded and sponsored by Shell and FAPESP, the Shell company in Brazil, and FAPESP is the São Paulo State Funding Agency for Research. And the center is hosted at the University of São Paulo. This is the headquarters of the Rcgi, and you're very welcome to join us after the pandemic for a meeting or a visit. But the Rcgi is a center is structured on 3 pillars. Of course, developing top-class research, generating knowledge and technological and scientific knowledge, but also making sure that this knowledge generated through research finds its way into the market and into companies promoting transformation. So this is what we call technology transfer or innovation. And also our third pillar is the diffusion of knowledge. So knowledge generated in academia in partnership with industry should not stay indoors, but must be diffused and disseminated throughout the society. So these are the 3 pillars of the Rcgi. Now, it's been a long ride so far, since 2016, and Shell and FAPESP and the University of São Paulo have invested a great deal of money in the Rcgi. And today we are here reviewing the first phase of projects that started in 2016 and are about to conclude in 2020. But also there are quite a good number of projects that started in 2018 and are halfway through that could be reviewed as well. And 1/3 whole program, which started only last year or 2 years ago, and is now coming to an end, coming to the middle of its phase in 2020. But now next year, we'll be starting the year with phase 3, with a bunch of new projects in the Rcgi, and I hope you'll be able to follow up with us soon on the review of next year. The center is quite big now, 370 researchers divided in 46 research projects, and the center is mainly structured in 5 research programs. The first program is engineering, then followed by physical chemistry, then energy policies and economics. And these 3 programs have been reviewed yesterday. So if you go back to the first video, you will find discussions about those 3 programs. Today, we're going to discuss and review CO2 abatement and geophysics, plus one additional discussion on human resources and diffusion of knowledge. So these are the 3 goals for today. So welcome to the Rcgi in Review, 5 years of gas innovation. And I'm very happy and grateful to FAPESP and Shell, our founding sponsors, for holding us together from the beginning. So this is the program for today. I kept the program from yesterday so you can see what happened yesterday. But here we are, the 1st of October. We are beginning now, followed by 3 short presentations, 20 minutes only, on the achievements, summarizing the achievements of CO2 abatement, geophysics, and Human Resources and Diffusion of Knowledge. Then we're going to have a break. There will be time for you to have some coffee, and we'll be back after the break with a very interesting perspective from Shell, presented by Alexandre Breda, who is Shell's representative in the Rcgi. And that will be followed by a live panel of discussion by all the participants of today. So I'm glad you have joined us today. And I think we are ready for the first, oops, not coffee break, I'm sorry. We're ready for the first presentation. And I would like to invite Professor Giulio Meneghini, who is our Rcgi Scientific Director, and also the Director for the CO2 Abatement Program. And Giulio will be presenting the achievements of the CO2 Abatement Program in the last 5 years. Hello, Giulio. Thank you for coming. And I would like to invite you to welcome, as the Rcgi Director, to welcome our attendees today, but also to start your presentation on CO2 abatement. Good afternoon.
Well, thank you very much, Gustavo. It's a pleasure to be here again. And today I'm going to talk specifically about the CO2 abatement program. And then I will try in this 20-25 minutes to give a short presentation of all those 16 projects that, as Gustavo explained, it started 2 years after the starting of Rcgi. It started in October 2017. And then we are in the middle, in the second half of that program. And then this is the list of the projects. And then, as you can see in our website, all the abstracts. And what I'm going to show is just a quick review of those projects, starting with project number 30, innovative process for CO2 conversion to high added value chemicals and fuels based on hybrid catalyst. And then the team is led by Liane Marcia Ross, and has also Renato Gonçalves, Romulo Andi, and Jorge Massini as the PIs working in that project. And then, as you can see, the main objective of the project is to develop some catalytic process for the conversion of CO2 into other high added value chemicals and fuels. And this is what is interesting, is because as the group is in the Institute of Chemistry of University of São Paulo, and people who are working there, they have a lot of experience with catalyst process. And here are some results, just showing some of the results of some catalysts, and these are results that were shown in the last review meeting made by Liane Rossi, and then it shows the spectra of some catalysts and the affinity with those with some of the reaction that they are interested in. And then this is one of the results that have already been, those results have already been published. And Liane is also now, I was very glad to learn that Liane became the editor, one of the editor of one of the most prestigious catalyst periodicals in the world. And then Liane is the coordinator of that project. Following to the project number 31, sorry, this project is what we can call as artificial photosynthesis, and how to find nano oxides and photocatalysts to do what we can call artificial photosynthesis. And the team is led by Professor Douglas Gouveia, and in the team also we have Guilherme Frederico Bernardo Lenze Silva, André Luiz da Silva, and Ricardo Ribeiro de Castro. And as I just said, the main objective is to find some organic material that can emulate or can give you artificial photosynthesis. These are some of their results that they obtained in the two first years of the project. You can see on the left a picture of the structure that they are using, the bed for the organic material, and is a porous silicate plate, and there is a very small area, and they are doing in their lab the experiments using this bed and the material, and you can see on the right hand side microscopic sample obtained through ablation of a certain wavelength and with 60% of total power. And then this is very interesting because we believe that University of São Paulo, Escola Polytechnic, and the group of Professor Douglas Gouveia is one of the leading groups in this area in Brazil. And they now have the capability of doing experiments, produce the bed and the organic material, and then to do the experiments to see what is the best organic substrate to have the maximum efficiency of the artificial photosynthesis. Well, following to the next project is project 32, modeling, simulation, and optimization studies on innovative CO2 conversion technologies. The team is led by Rita Maria de Brito Alves from the Department of Chemical Engineering, together with Claudio Oller, Antonio Ezio Bresciani, and José Eduardo Alves Graciano. And then the objective of this project is to try to model and simulate those conversions technologies, innovative conversions technologies. And here is some data that they presented in the previous results in terms of efficiency. To have first, of course, you have to, before doing the CO2 conversion, you have to do the capture, and then they in the first year they did a complete review of different techniques for CO2 capture, and now they conclude the project. This is one of the projects that has been concluded in July the 8th, and then they presented the best materials for capturing CO2, and then the next phase for the CO2 conversion. We are looking for sponsors for the next phase. As I said, the project was concluded 3 months ago. Project 33 is a project led by Lenilson Rodrigues Padovese from the Mechanical Engineering Department of Escola Polytechnica, and is a passive acoustic technique for monitoring CO2 leakage and some results. And I would say that Lenilson has a lot of experience working with acoustic signatures of different kinds of phenomena. For instance, even animals, aquatic animals, to have the proper signatures of whales and so on. And these are the results that he obtained after the first 2 years of the project, in terms of having the signature and the leakage detector signal from 100 meters source from the sensor. And also the spectrogram. You can see on the right, for those who are acquainted with acoustic techniques, this is something that's it's quite difficult sometimes to how can I say, to identify a proper signature, and then he succeeded to do in terms of bubbles that CO2 would release when you have a leakage, for instance, at a certain point of the ocean. And the project 34, I've already presented some results yesterday, and one figure that shows all the results, and this is one of the projects that has a lot of impact in scientific terms and also in technological terms, is to study and investigate the feasibility of having huge caverns built in the salt layer of the pre-salt region, not only to store CO2 and methane and associated gas, but mainly to do what we called gravitational separation of CO2 and methane. The team was led by Gustavo Assi and Claudio Miller Sampaio, and the team had Kazu Nishimoto, myself, Marcelo Ramos, Belmiro Mendes de Castro, Celso Pesce, André Mendes, Álvaro and Pedro Maia, Edgar Borges Maia, Felipe Ruggeri, and Guilherme Rossetti. And then one of the main figure that explain everything in the project, as I explained yesterday, when you have, let me just put here a pointer, and when you have, for instance, the geological formation that's typical in the pre-salt reservoirs, and this is public data you can find in ANP, in the agents of oil and gas, the Brazilian agents of oil and gas, all the positions of the wells and even data regarding the composition in the subsea layers in the reservoir. And what we usually have is a water depth that varies from 1,500 to 3,000 meters of depth. Then you have a layer, a sedimentary layer, is where the oil, the post-salt oil and gas is located, the reservoirs in this region here. Then you have a huge salt layer that we use as a hypothesis that it was pure halite, NaCl, pure salt. And then here, this layer can have a height from 1,000 to 2.5 thousand meters of height. And then it's possible to have caves that are built using a technique that's already been developed to build caverns in salt. Is a technique. The techniques are well known since the early 1950s. This technique was developed and so on, and even to do in very deep waters is not so difficult. And then the idea that we came up 2 years ago, it was to have the cave to store the associated gas, and as the pressure is very high for us, it's only a matter of knowing where the cave is in relation to the free surface of the sea in that position. And then if you have a cave that the top of the cave is located at a depth of around 3 to 4,000 meters from the sea level, you have here a pressure that is the pressure and a temperature that CO2 and methane are both in supercritical condition. What does it mean? It means that they are neither a liquid or a gas. They are in a phase that's called supercritical. And what's interesting in our case, that the density of the methane is much lower than the density of CO2 for that condition in the supercritical regime at that pressure and temperature. And then CO2 would go down, and methane, as methane is much lighter than CO2, it will stay at the top of the cave. Of course, as both are in supercritical condition, and you don't have a free surface separating both fluids, there will be few CO2 at the top and also a little bit of methane at the bottom. But the bulk of CO2 will remain at the bottom, and the most volume, or the most of the methane will stay at the top. And then it's possible to separate in a very easy and efficient way. And then these are the advantages that I showed last year. And just to remind that the process of gravitational separation of CO2 and methane has been awarded the ANP Innovation Prize last year. Following to project 35, well, I'm sorry that this slide is in Portuguese. I just noticed that in our website is still in Portuguese, and is a project that is another acoustic technique to detect leakage from the bottom of the sea of CO2 and methane. But in this case, it's not a passive technique, it's an active technique. And then you send a signal and you receive the echo of that acoustic wave, and then you try to identify where the possible leakages are. And when I saw this figure here 3 or 4 months ago in the report, I said, well, where is the baby? It looks like a ultrasound scan of a pregnant woman, but that's not the case. It just looks like. But the technique is very similar to ultrasound that you use for scanning your body. And then if you have an experiment where you inject bubbles and of gas in a liquid medium, you can have you can first detect using high-speed cameras, using a visual approach, and you can do also the same using acoustic waves, and then you can correlate and see the signature of the bubbles, and then you can identify, considering the size of the bubble and the position at what pressure and temperature that bubble is, you can identify if the gas is methane or CO2. And this was a project that has already been concluded as well in a very successful way. Going to project 36 is our geological project, is to find possible sites in Brazil to do CCS, carbon capture and storage, not only carbon capture and storage offshore, but also onshore. And then after the first 3 years of the project have been completed, they just passed now. The project, the first 3 years were completed last month in September, yesterday to be more precise. And then the group led by Professor Colombo Tassinari from IEE, and with a team of geologists, Carlos Grossman, Claudio Ricomini, Edmilson Moutinho Santos, Fabio Taioli, Lígia Barroso, Lucy Santana, and Richard Abraham Jr. They evaluate all the possible sites and all the different techniques for CO2 storage. And then this project was very successful. And in the next phase of Rcgi, we intend to concentrate our attention to the onshore sites where you can do CCS, and then it would be in the BECS program, Bioenergy Carbon Capture and Storage Program. And then we are going to do a map, not only offshore, but onshore in São Paulo state and in the Paraná Basin, where most of the ethanol production is, and in Brazil, in order to do the BECS. Following to project 37, this project is also related to CO2 in supercritical condition. I'm sorry again, because this is in Portuguese, but is the idea here is to be able to simulate and then optimize the design of compressors for CO2 in supercritical state. And then usually the compressors that you have in those, for the applications in the pre-salt region, as you have high pressures, you start with CO2 that's in the compressed state. And then as you are following the different stages of the compressor, in the final stage, you have phase change, and then the CO2 goes from compressed CO2 to supercritical CO2. And then this is the main task. And then the team is led by Professor Jurandir Yanagihara from the Department of Mechanical Engineering of Escola Politécnica, Emílio Nelly Silva, Fábio Saltaro, Sérgio Frachino, Paulo Eduardo Batista de Mello, Daniel Desan, Leandro Salviano, Julian Sainz, Junutula Red, who is a professor in the University of Texas, and Patrick Farrell, who is a professor in the University of Oxford. And they are part of this project as well. And this, what I'm showing are some simulations using different techniques. And it's a very difficult task to do simulations for those compressors, because you are, as you have a very high rotation of the compressor. Those compressors can go up to 10 to 15,000 RPMs, and you have turbulent flow, you have CO2 that change phase, and then is a huge task. And then in the first years of the projects, they managed to do simulations and then to validate the simulations, and now they are progressing to parametric and topologic optimization in order to use this brand new technique that Professor Emílio Silva and his group is working with. And they are proceeding to the optimization of the shape of the blades of the compressor. And then following the next project, 38, the high efficient ejector for gas compression, is a project led by Professor Rafael dos Santos Joria, who is from Escola Politécnica in Santos. And I'm also part of the team. And this is in order to investigate and also to be able to simulate and get the efficiency of a compressor, a high efficient compressor. And what is a high efficient compressor? Usually you have here a fluid that goes towards a contraction, and then the pressure decreases a lot. As you increase the velocity, the pressure drops very much. And then you have another fluid that is, you have the suction of this other fluid, and then you have here a mixture of those two fluids. And if you have, for instance, a liquid and then a gas, you have a two-phase flow at the downstream of the ejector, and then you have just to separate the gas phase from the liquid phase, and the liquid is the working fluid that is used only to do the suction of the gas. And if you have a pressure difference, what is really the ejector doing is to compress this gas, for instance. And then we are also employing parametric and topology optimization to have the best shape in terms of efficiency, because in reality, for a very narrow range of pressure difference, these ejectors are very efficient because they don't have moving parts. Apart from the fluid, the liquid, usually the working fluid that must be compressed through a pump, usually a pump, the gas and liquid, you don't have moving parts in the ejector, Of course, for the liquid to move around the ejector, you need a pump. But apart from that pump, there are no moving parts, and there is no possibility of leakage, because usually you use a tank, a horizontal tank, to separate the liquids from the gas, the gas fluid, and then it's quite easy to avoid leakage. And then project 39, that I also showed some results yesterday, is the development of a gas supersonic separator, optimization, numerical simulation, and experiments. The team is led by Professor Bruno Carmo, and we have myself, Emílio Nelly Silva, Hernando Volpe, José Roberto Moreira, Claudio Oller, and Gerard Gorman from Imperial College. And now we have a new group that started working this project 3 months ago, João Azevedo and Ricardo Galdino from CTA, and who are now part of the project. And the main goal of this project is to design what we call the new generation of supersonic separator. And this, what I showed, is our patent that we filed for a patent, I believe that was last year. And then the design that we are proposing is this, but now we are doing a lot of simulations to validate our codes, the codes that we are employing, and we are starting also the topology optimization part of the project. What you see on the left are the simulations. It's very important to not only to validate, but to study the swirl that you have to generate in order to separate the denser phase from the lighter phase of those two gases that you are separating. And then to increase the swirl is very important. To increase the swirl without spending too much energy, that's the main point, in order to have a very efficient separator. And then we are in this phase of the project. And on the right, I'm very glad to announce that the lab is ready. Simões, Professor José Simões has already completed the lab, and the lab now is ready to be inaugurated in the next couple of weeks. We are only waiting for the end of the confinement due to COVID-19 in order to have the inauguration of the lab, in which we are going to simulate in a scaled model the supersonic separator. And project 40 is related to corrosion, to study the materials that to do a a bibliographic survey of materials employed for pipes carrying CO2 and methane, and also other gases, and also to see the possibility of developing other kind of materials, and also to study, for instance, composite materials. And the team is led by Professor Helio Goldenstein, and in the team we have Professor Ercílio de Mello, Professor Sérgio Fracino Miller de Almeida, and this project has concluded this review phase, and we have now also a lab to test new kinds of materials and how corrosion and the process of corrosion, or how you can avoid corrosion with those materials. The lab is already set. This project has been also concluded 3 months ago, in July the 8th. Project 41 is a project that started with numerical simulation employing what we call multi-scale CFD. The team leader of the project is myself, even though now Professor Caetano Rodrigues Miranda is I would call the co-leader of this project. He started last year working with us, and in the team we have Alexandro Kirsch, Adriano Grigolo, Caetano Miranda, as I just mentioned. Now he's the co-PI of this project, Professor Iberê Caldas, Professor José Roberto Piqueira, Professor José Aranha, Nair Hayasmara, and Thiago Visconde. Those who are not professors in University of São Paulo are postdocs in the project, and the team, we have PhD students and scientific initiation students as well. The project started with what we call fluid material interaction, in order to study how the non-slip boundary condition changes as you have hydrophobic or hydrophobic material in the solid wall, and how it interacts with different fluids. And then the project, after the first couple of months, we did some kind of diversification of the project and start 3 different lines. And those 3 different lines, one of them is to have what is called not a digital rock, but is a digital cube that's filled with some kind of fluid that can be a mixture of CO2 and methane, for instance. And then you apply a periodic boundary condition on all faces of that cube. And then you have a pressure and temperature that cube is under a certain pressure and temperature. And then using molecular dynamics, you can get the fluid properties of that mixture. And what is interesting, that our group is one of the few in the world that are able to do the simulations, and then we are going to be able, we are already able to do the validation, because the supercritical CO2 and methane in supercritical condition lab is already built and operational. And I'm going to talk about that lab soon. And then what I'm showing here is a sample of some thousand of CO2, 20% of CO2 and 80% of methane. And on the right, you see some physical properties of that mixture obtained for different pressures and for a given temperature, 313.15 Kelvin. The physical properties of that mixture and now they are ready to do our validation in the lab that Claudio Waller and Professor Basito, the project that they are leading. And what's important for us to have this possibility of getting the fluid properties for any kind of mixture at any temperature and pressure. We have to use that data to do the simulations of the supercritical compressor that you just saw, the project led by Professor Jurandir, and also for the project of the cavern, to simulate all the process of filling the cavern with the mixture of the associated gas in supercritical condition. We need to have the data. And then what the oil industry use are very simple empirical models that can fail at certain conditions. And with this approach, we decrease a lot the uncertainty of the simulation. And then you decrease a lot the risk of failure of your engineering design of the cave, for instance. Going to project 42, this is a project that's divided in two main lines. One is the environmental impact assessment of CCS activities in Brazil. This part is led by Professor Evandro Mateus Moreto. And in the team, we have Alexandre Simão, Ana Luisa Fontenelle, Driele Peril, Luiz Guilherme Zacarias, Márcia Regina Conrad, and Karim Mascarenhas, together with Thalita Pontes. And the other part of the project is the legal aspects, which is led by Irda Catarina de Medeiros Costa. In the team, we have Raíssa Mussara, Silvia Cupertino, Romário Carvalho, Israel Lacerda, Isabela Morbach, and also Karin Mascarenhas. She's working both lines of this project. And then, starting with these legal aspects, as we mentioned yesterday, we have, I believe, 4 books that have been published by Irda and co-authors, but led by Irda de Medeiros Costa. And we have the Rcgi Lex that was part developed in phase 1, but also in this project of phase 2. And the impact of Rcgi Lex was huge, and the books that are now being translated to English are going to be, I'm sure that they will have a very high impact in the area. And the first line of this project, the environmental impact assessment of CCS activities in Brazil, it's a very interesting area of research, because in phase 3, this is going to have a link with one of the projects that are in the advocacy program related to social license to operate, to social perception, and so on. And then I think that we started in what we call phase 2 of Rcgi, but we are going to continue for another 5 years in the advocacy program. The legal aspects as well are going to be the legal and standardization and the normatization aspects of CCS, for instance, and CCU and BECS are going to be investigated in phase 3, also led by Edmilson, Irdan, and Alberto Foss. And now, just to complete the final 3 projects of the CO2 program, is the determination of the fundamental properties of what we call the gas mixtures for that are of interest for the gas and oil industry. And mainly in supercritical conditions. And when we talk in supercritical conditions, we are mainly focusing in high, very, very high pressures. The temperature is not very high, around varying from 20 or varying from 4 Celsius to 60 Celsius, but the pressures varying from 10 to 600 bars. And this is one of the few labs in the world that are going to focus on obtaining the thermodynamic properties like viscosity, CP, and other properties, solubility of one substance in another in supercritical conditions, how much is the solubility of that substance. Everything is going to be investigated in this lab, and I'm also glad to, as I said, just to say that Claudio Waller and Reinaldo Basito are going to invite you all and who are interested in participating in the inauguration of the lab. Project 44 is the laboratory for tests of the supersonic gas separator, and I just mentioned the project 39 mainly deals with the team and with the labor force to the investigators and the researchers who are going to work in this lab. And as I said, it's also ready to start its experiments, and the inauguration are going to be in the next couple of months. And finally, this is the project that is also led by Reinaldo and Basito, in which all the main power of those experiments of the lab for CO2 and methane and other gas in supercritical conditions are going to be in the lab that they are going to be carried out, the experiments. And this is the project that all the scholarships and the main power are in are allocated. And these are review. As I said, this program didn't start 5 years ago. It started almost 3 years ago, in October 2017. It's going to be 3 years old, this program, in the next couple of weeks. Then thank you very much again to our sponsors, the founding sponsors, FAPESP, Shell, and USP for giving us all the support and the physical space, and the professors and the academic members of staff of Rcgi. I would say that 70 to 80% are from USP. Thank you very much, Gustavo, and I'm sorry for extending a little bit my presentation.
Thank you, Julio. Thank you for your presentation of the CO2 abatement program. If you have questions for Julio for the live discussion we're having later after the break, please do type them in the live chat just now, okay? We will move immediately to Professor Bruno Carmo, who is the director of the geophysics program. Hi, Bruno. Thank you for coming and for presenting to us today. Professor Bruno Carmo will now present the highlights of this geophysics program. Okay, Bruno, you have your 20 minutes. Thank you.
Thank you very much, Gustavo. It's an honor and a pleasure to be here today to talk about this geophysics program. The program of which I'm the director. It's a program with just one project, so I'm also the project coordinator. I also participate in other projects of the Rcgi, in the engineering program, and also in the CO2 abatement program. And it's an honor to be part of this team, to be the deputy scientific director of the center. So with no further delay, I'm going to talk about the achievements of the project number 46, which composes the geophysics program. Okay, so that is in fact the presentation about the project 46, STMI, Software Technologies for Modeling and Inversion, with applications in seismic imaging. Okay, so what is this project about? Okay, so it's a bit different from the other projects that we have seen in the first and second day. Okay, we are linked to another sector of Shell. So our main objective here is to develop software technologies for high-performance numerical simulations and to solve inverse problems, which could enable scientists and engineers to develop and test models easier and faster. Okay, so there's a very strong component of software engineering here in this project. Okay, our team is composed by different specialists. We deal with numerical methods, with numerical modeling, with compiling technologies, machine learning, and all sorts of subjects related to high-performance computing. Okay. The key characteristics of this project are the high level of abstraction, automatization, layering, flexibility, portability, performance, and integration. So our idea here is not to develop the solutions for the energy industry, but to develop tools that the professionals of the energy industry could use in a very easy way to test new models in a much faster way if you compare to what happens today. Okay, the main application, we have a main application in mind here, is for geophysics and seismic imaging. Okay, so that's being illustrated here on the right. Okay, so you have this kind of survey when you have a air gun that blows acoustic waves here on the sea, and those acoustic waves go down to the subsurface, reflect on the different layers, and go back to the array of hydrophones that could be floating here or even stored on the seabed. Okay, so this kind of survey can be used for many different things, for oil reservoirs, gas reservoirs, but also for CCS sites. Okay, this is the newest project of the Rcgi. It started 2 years ago, and they will continue for at least 2 more years. In terms of the project overview, we are composed by 5 different work streams. The first one is devoted to finite difference algorithms for direct and adjoint problems. Second one deals specifically with the adjoint models to try to develop algorithms for automatic generation of those adjoint models that would be very useful for the domain application engineers, so they don't have to bother with that. That is done automatically by the software. We have the workstream number 3, which involves developing optimized high-order discontinuous methods for modeling and inversion. So here you have finite difference methods, and here you have finite element methods, so different numerical methods. Fourth is automatic generation and adaptation of unstructured meshes, which has a strong link with workstream number 3. And 5, we have compiling technologies and performance portability as the main goal, but the team is also working with different methodologies to perform full waveform inversion, which is the main technique for the seismic imaging that we are investigating. Our current team has 40 people from different departments of Schola Politecnica, mechanical engineering, mechatronics, computing. Okay, those are the 3 main departments, and also mining. There's a very large team from the Institute of Mathematics and Statistics. Some people from the Federal University of São Carlos, and also some people from the Federal University of Santa Catarina. So we have multi-departments, multi-unities in the University of São Paulo, and multi-institutions in terms of different universities. 10 faculty members, 11 postdocs, 9 PhD students, 3 master students, currently 5 undergrad students. We have hired 1 software developer and TI administrator, and 1 admin staff. Okay, and we have a very strong international collaborations. So far, we have had 6 visiting professors. We would have had more if the pandemic didn't take place, but unfortunately, all the travel was stopped. But we maintain frequent contact with those professors that have visited us in the past, and we hope that we can invite them again, invite other people to come here and collaborate with us in the next year until the end of the project. So that's the schematic way of showing the different work streams. And we also had an infrastructure project that also had the goal of providing new office space, because we had a very large team in a topic that was not on the portfolio of our lab before. So we have to provide new space for these people, okay, and also to install and access a variety of different computational architectures for testing all those software. As I told you before, portability was one of the main characteristics of our proposal. So we needed to test our softwares in different computational architectures. Okay, so I'm going to highlight some of the main achievements that we got during the first 2 years in each of the work streams. Okay, the work stream number 1, which deals with finite difference methods. They were successfully implementing implicit solver for wave propagation. That's traditionally carried out with explicit solver. So implicit solvers have many advantages that we want to explore in the next few months. There's a team there led by Dr. Antoine Lohan, implementing sharp interface models to identify this kind of, for example, salt bodies in the subsurface. And also another team devoted to the implementation of absorbing boundary conditions when they're dealing with this kind of inverse problems with seismic imaging. Having an absorbing boundary condition is really crucial to have a result with good quality. Okay, so those are some results that he got in terms of dumping the reflections, the spurious reflections that wouldn't happen in the field, but would happen in the in computations that you carry out in a finite domain. Okay, the workstream number 2, sorry, I forgot to mention workstream number 1 is led by Professor Saulo from the Mathematics Institute. Workstream number 2 is led by Professor Hernani Volpi from the Mechanical Engineering Department. It's devoted to adjoint models. So their achievements so far were the adjoint formulation of the absorbing boundary conditions. So here we see the integration between workstream number 1 and 2. There's a very strong aspect of this project. So we didn't want to have 5 different projects. We wanted to have one single project with 5 work streams that would talk a lot with each other. Okay, so that was one of their main achievements so far. So we see some of the results here. Okay, we also had checkpointing for FWI, which is a functionality that's necessary for performing these high-cost simulations without resorting to a lot of memory. Okay, so this is a collaboration between workstream number 2 and workstream number 3 mainly, and the development of multi-parameter FWI is something that's being developed inside there. Okay, workstream number 3, which is devoted to the high-order finite elements applied to seismic imaging. The main achievement has been Spiral, which is something that we're developing together with workstream number 4, because we wanted to have a software that would embed not only the finite element aspect, but also the mesh generation, because if you combine both of them, okay, you get the best potential of this approach to solve the seismic imaging problem, okay, the FWI problem. Okay, so Spiral is a Python library for modeling acoustic waves in the subsurface. It's integrated with the mesh generation, which I'm going to talk about in the next slide. It has different finite element types available, different time integration schemes, different absorbing boundary conditions, and perfectly matched layer. It has been extended to 3 dimensions, so it can run 2 dimensions and 3-dimensional simulations, and also is parallelized with short and stable parallelism. So it's a very nice software. We are very close to making it very available to the open community. But currently we are performing some final implementations and final tests. And we're able to get FWI results using continuous and discontinuous finite element methods. Okay, so it's a very nice piece of software that has been developed in the project on the top of an existing finite element code, which is called FireDrake. But all the stack above FireDrake were developed by the people in the project. I'm very proud to say that. Okay, the main achievements of WS4, the workstream number 4 deals with mesh generation, but also with machine learning techniques applied to this problem. Okay, so the main achievements of this workstream, which is led by Assistant Professor Dr. Rafael Gioria from the Mines Department, is Spiral together with workstream number 3, which I'm just talked about, but also the mesh generation bit of Spiral, which is called Seismic Mesh. It's a very nice code for mesh generation for this kind of problem, okay, for seismology and written in Python. Okay, it's about to be published in the Journal of Open Source Software and has been thoroughly reviewed, and something that's not available in the market nowadays. And much of the use of finite element for seismic imaging hasn't been possible because there wasn't a mesh generation code devoted to this kind of problem. So we intend to fulfill these needs to close this gap. Okay, and the other bit of workstream number 4 is related to the seismic imaging using machine learning techniques. So here is a picture that was taken out from a conference paper that has been published and just presented this month, last month, actually in September, and that shows the implementation of a neural network to perform the seismic inversion here. Okay, so we have the shots here, and using this neural network, we can get the velocity model. Okay, so this is under development. It has very nice results. There's a lot of exciting science and exciting new technology behind that, and we are very happy to be at the leading edge of this kind of development. Okay, finally, the workstream number 5, which is devoted to performance, basically, but also to other techniques applied to seismic imaging. Some performance evaluation of one of the codes that we use for finite difference, which is called DeVito, were performed on Intel and ARM processors, so different types of chip technology. Okay, so you see some results here of speed up. Topology optimization, which is a technique that Julio talked about a lot in the previous talk, which is also being applied here for seismic imaging. This workstream, it's not strange to say that's led by Professor Emilio Silva, which is also the deputy coordinator of this project. Okay. It's been showing very nice results. Okay, I'm showing some results here on the bottom right of this slide. And the team from Santa Catarina is also applying a level set method to inverse problems. We see here something that's very well related to the sharp interface models that I've shown before. So there's 2 teams working with this identification of salt bodies, which is something that's very relevant for the industry, and particularly for the oil and gas industry in Brazil. Okay, we also had a front related to the infrastructure. Okay, so we had 2 main objectives. This part of the project actually ended in the beginning of this year. So we had the mission of providing some new office space in our lab, the NDF. So this is a picture of the new rooms, okay, the refurbished rooms. What was the plan before, and here is the the rooms just before the pandemic. Okay, that's in the beginning of the year. There are some researchers working here, so I picked a picture that has three postdocs from our project and one PhD student. So you see that the guys from the STMI project are very hardworking. Okay, and we have a very nice classroom here. It's located here. Okay, so we could provide this new office space, and we were able to deploy a new cluster with different technologies. So it's not like a very large cluster, it's fairly small actually, but it has different kind of processors. So we have like Intel processors, AMD processors, ARM processors, okay, and also different types of accelerators like GPUs and FPGAs. It has been very useful to count with this kind of infrastructure to perform the different tests, to perform the different tests for compiling, for performance, and things related to the more computational computing science aspect of the project. Well, the research outcomes, as I told you before, this project is young and has this particularity of being about a topic that no one here was specialist before. Okay, we don't have any, we have 2 geophysicists in the project. One of them started by the end of the first year. The other one is a PhD student, so it's not even like a faculty member. It's been very helpful. I'm not saying that that's not helpful to have those people here. It is. But that's a fairly new area for most of the team. And even although we have that characteristic in the project, we are able to publish 3 journal papers, 7 international conference papers, and there are many more to come in the next 2 years. Okay. Other contributions that are very valuable but not very well advertised by many of the projects is that all the project here is open source. Okay. So everything that we do is available to a wide community around the world, and we have been making contributions to existing open source software, namely DeVito and Firedrake, and we have also our own open source software, which are Seismic Mesh and Spiral so far. So Seismic Mesh is already available in GitHub. Spiral is going to be available very soon. And with that, we provide some new tools for the community. And this is a very nice contribution for the world, actually, not only for the Brazilian society, but all the academic community and application domain community. Okay. And the last point that I would like to stress is that this project was made the ground for us to put a proposal which constituted the CADASE project, which involves many other projects that are related to high performance computing applied to energy, which provided us with some computing hours in the Santos Dumont supercomputer. Santos Dumont supercomputer is the biggest supercomputer in Brazil. Okay. So with that, we provided some computing hours for other projects of the Rcgi, for example, okay, the supersonic separator, the molecular dynamics. And so that was very nice to get all those people together. We were able to put together this very strong proposal that could secure us a lot of computing hours in a time that we were not able to spend on cloud computing and other stuff because of all the cost reductions that we had to face because of the pandemics and also because of the reduction of the income of Shell. Okay. So that's it. I would like to thank Gustavo again for the organization of this workshop, and especially Shell for sponsoring this project as well.
Thank you, Bruno. Thank you very much. Thank you for your nice presentation of Project 46, and also that makes the geophysics program. And if you have questions for Bruno, as Stephanie just sent now, we won't have time to answer them just now, but I'm sure Bruno can bring up that topic in the discussion, okay, after the break. So please do keep sending your questions and comments for discussions in the live chat. Now, I'd just like to remind you, if you have not registered for this event, if you're just attending and watching on YouTube, we would like, if possible, that you join us going into the Rcgi website, and then just type in your email address and your institution and your country, so we know from where you're watching. At least then you get to know more and receive more information about the Rcgi and other live events on our channel. Okay, and if you have not already subscribed to our channel on YouTube, please do that, just clicking on the subscribe button down here. Right, I think we're moving to the last of the three presentations of this afternoon. And this is a double presentation between Gustavo Assi, myself, and Karen Mascarenhas. So I'd like to invite Karen now to come alive with us. And I will start very quickly presenting, there she is, hi Karen. I'll start presenting about diffusion of knowledge, and then Karen will follow up with a presentation on human resources and leadership, okay? So Karen, bear with me for a moment, and I'll pass on to you later on. So I would like to quickly present some achievements from the diffusion of knowledge perspective. It is not a program of the Rcgi, but we believe some of the other areas that serve the organization of the Rcgi are more or less like programs in themselves. And diffusion of knowledge, innovation, human resources, leadership, and so on and so forth are all important topics to be discussed and reviewed. Well, just to remind, as I said in the beginning, the Rcgi is structured in these three parts, and diffusion of knowledge is a key part in disseminating the research results that are generated in the center. So we cannot take for granted what we have done in this third arm of the center. That's why I would like to present some achievements and maybe open the discussion for some challenges and vision for the future later on. Well, we have a motto, our lemma in the Rcgi when it comes to diffusion of knowledge, is that a project is only concluded when it is properly communicated. So until you have not communicated your project results properly, by means of a publication, scientific publication, a conference, an article in the open media, or a video communication of some sort, the project's not finished yet. So we give good emphasis on communication and communicating the results. Now, we all see that there are several levels of communication. And dissemination of knowledge is not just putting out the information, but is targeting specific audiences and making sure that that specific information will be understood and grabbed by that specific public. So here in the Rcgi, we see kind of four spheres that we have to communicate with. The first one is what we call a type of internal communication, aiming at the Rcgi community, the researchers and everybody working with the projects, but also with Shell and FAPESP, who are the main stakeholders or the main sponsors of the center. And for this public, there's a very specific way of communicating or disseminating knowledge. There's a specific language, there's an identity, and of course for them there are a lot of useful tools that we can use because they are all in-house and they are members of the center already. Now there is a second wider sphere which I'm calling academia, and that means we have to find a way to communicate and disseminate knowledge to those peers who are around us, those academics, and especially those who are working in partner institutions. Right, to communicate with academia also requires a very specific language. You have to understand what people want to hear and how to communicate and reach out for them. There is still a third sphere, which I'm calling the science and technology community. It's a broader sphere, and it represents those people in the world who are consuming information about science and technology. And for those people who are out of academia, but are, for example, in businesses and companies and in the industry, you need to target them with a special way to communicate your information as well. And finally, there's the fourth sphere, which is the general public. And if you want to have an impact on the lives of people in the society and the next generation, for example, you ought to communicate with the general public in a very specific and productive way. So in the RCGI, disseminating knowledge is not resumed or reduced to one of those perspectives, but it requires a broader view of how to communicate on all those four aspects. Now, the area of diffusion of knowledge in our center, which uses a lot of communication sciences, we like to say is an area that is at your service to the RCGI, meaning that it is a support area that gives support to all the other programs and all the other projects. So here, at the same time that we have our specific goals as a science of communication is being developed and applied, we also serve all the other projects that might have some interesting results to share and have to be tackled by the diffusion of knowledge actively in order to get this information out of the researchers and published out to the field. So through this last 5 years, along these last 5 years, we have developed quite a few activities, and they vary from a visual identity, creating a website, everything that you would believe it's normal and necessary for a center to exist, all the way to very specific training sessions, workshops, scientific events, and specific technical videos and interviews, for example. And today, in order to highlight the main achievements or the strong points that we learned, the strong lessons that we learned in the last 5 years, of course, I will not describe everything that happened in all these dozens of activities, but I would like just to focus on 4 of them as the highlight for the past 5 years. Of course, if you have questions and if you're specifically interested in any of those activities or topics that I'm showing here, please just send in your questions that I'm more than happy to spend some time explaining them to you later. So the first one I would like to highlight is what we're calling an identity. It was very important for us from the beginning that the RCGI could be seen with its own identity. Why that's important? Because we are in the interface, we are in between different identities and different categories. At the same time that we are at the University of São Paulo working with researchers and faculty members, we are not the university. And at the same time that we are working very close to Shell, we do not belong to Shell. And at the same time that we are sponsored by FAPESP, we are not just one research project from FAPESP. So what are we in this area? How do we identify ourselves? That's why from the beginning we decided that the RCGI would carry its own identity in terms of visual communication, in terms of activities and language, but always remembering that this identity also shares some characteristics of the 3 stakeholders, in special USP, FAPESP, and Shell. So creating this identity in terms of events, t-shirts, souvenirs, logos, material, printed material, website, was very important to give the center its own identity for the researchers and also for the public outside. So this was one lesson learned from the beginning. Now, the second highlight comes from what we have done looking inside the center. So the internal communication or the internal events in the form of workshops. In order to give the center this organic characteristic that everybody, all the 46 projects are related somehow to one another, so that the center is not just a hub of projects organized and brought together. It's more than that. It's an actual organic center where all the projects need and have to interact with each other. We created what we're calling the internal workshops of the RCGI. And every year, twice a year, we gather to discuss all the achievements and the progress of the projects. And this became very important for us. So promoting workshops, internal workshops, to allow people to come together, to know each other, to understand the progress of the colleagues and how those projects are developing, and actually to bring ideas to your project from other perspectives is very important. So I do recommend that centers with this characteristic organize internal workshops as often as possible. Now, my third highlight goes to what we're calling professional journalism. And this was key to the RCGI from the beginning. If you understand that researchers and academics are very good in doing their job of generating knowledge, discovering how the natural world works, they might not be very good in writing a piece of communication or a material to be published to the wider public. I mean, we just do not have this kind of training, and we're not specialized in that. So from the beginning, the RCGI understood that we required someone to bridge our gap between the knowledge generated in the center, the research, the faculty members, the labs, all the way to the general public and those spheres that I showed you before. And we decided to do that by calling or inviting professional journalists, people who could translate that information in the language that the public would understand, but also that could grab the information and send it to the right media, trying to pitch that publication, for example, in the television, in the newspaper, in an open and broad circulation magazine, for example. So without the help of an agency, a journalism agency, we would not be able to reach out to the wider public. And we see the impact when a text or an article is very well written. We see the impact of terms of the amount of people who read and interact with the center and actually come to the center to visit the other projects as well. And the company, the group that we invited and we hired was the Academica agency. And along those 5 years, Academica has published hundreds of pieces from our projects. They went interviewing all the researchers, all the 46 projects. They covered and produced material from all our events, and they managed to put out some very nice articles in the open media as well. So that is also very important for dissemination of knowledge, is to recognize that we academics and researchers cannot do everything, but we need to count on and rely on professional help. It's a shame not everybody recognizes this bridge as necessary. And in a way, for example, hiring this kind of support is not qualified for some agencies. For example, in our environment of ANP, this money is spent on this kind of journalism is not a levy qualified money. So there's something to be improved here in the way we manage and we organize our projects. Now, my final highlight goes to what we call in the scientific events. Of course, within academia and the scientific community, everybody understands this language of a scientific event, a conference, a meeting, a congress. So in the RCGI, we decided from the beginning to hold every year one big annual event and to try to make that scientific event to grow in impact and relevance to the wider community. So we started with what we call the SGRI, Sustainable Gas Research and Innovation. And we held 3 SGRIs, and they grew in number. First one was in a small hotel meeting room. Then we had to go up and up in terms of scale. And we had SGRI events in 2016, 17, and 18. But then we grew larger than we thought. And in 2019, we transitioned to what we're calling the ETRI, or the Energy Transition Research and Innovation, giving to the RCGI this language that is much wider than just sustainable gas, but giving to the RCGI a voice in the energy transition scenario. And we had our first ETRI, or Energy Transition, last year, 2019. We were hoping to have one in September, October this year. Of course, due to the pandemic, that has had to be postponed to next year. Perhaps E3 2021 is coming up soon. Okay, so holding scientific events is a way to exist and to have a voice within the academic circle and also the science and technology circle, because that is credential everybody understands. And if you speak and exist in terms of a scientific event, peer-reviewed with good quality publications, then of course you have something to say and you are respected for that. So organizing scientific events was a highlight of diffusion of knowledge as well. And that's my contribution. Those are my highlights from diffusion of knowledge. And then I would like now to invite Karen to give her own perspectives. Karen, if you could share your screen with us, I would put your presentation up.
Oh, okay. Okay.
There you are. Okay, Karen, you can go now.
Okay. Okay. Well, good afternoon, good night, good morning, wherever you are. And it's a pleasure to be here with you all today. And I would like to share a brief presentation showing a bit about the results of the Center and of Human Resources and the administrative area too. So sharing some things that I suppose you will like, because it's a bit of our identity, as it's so important for us to have this identity, as Gustavo just mentioned. So I would like to start here where it doesn't move. Sorry for that. I probably have to. Let me do it again. Okay. Well, see if now it goes. Okay, there we are. So here's our administrative center, as you must know, but if you don't, it's very nice to go and see it. And as soon as we get back, which we are dying to go back to our space, which is very nice. Here, I wanted to share an idea, which is the triple helix innovation model, which is something that we are also studying, and which is very interesting because it's the model which FAPESP designed or is structured for us to have what is the Rcgi, which is it's structured in an open innovation model where it has the participation of the university, of a company, and also from FAPESP. And this is very important because the three have to work together, because that's the idea, to bring into innovation into the market. So the idea is to work with that. And so each one is concentrated in their own goals, of course. They've got their own perspective, like, for instance, the university with science and research, working with discoveries and new solutions, but working together with the company with things that can be applicable for the company or for that industry. And also then sponsored by the funding agency, which also has interest in growing locally in those aspects. So this is very interesting. And so to deliver this by licensing or startups of the innovation of the technology that has been developed in the center. So this is pretty much also what Gustavo was saying when he says there's diffusion of knowledge, because it's an open innovation model, which means FAPESP wants this to be shared. So that's why publications, and we've got a lot of this dissemination of knowledge, and also by the technology transfer and innovation, and really the research. So this is the idea when we talk about this triple helix model. There's a study also for this for many years. The first time they talked about this was in '96. So you see that this is something evolving very, very fast now. Just brief history about the Rcgi. It's that it started in 2013 by 4 professors which got together, and they wanted to answer the call for the FAPESP call for a CEPID, which is the Center in the way I just explained to you. And then the idea was they developed and got people working together. This is something that's very interesting because there's teamwork all the time, to put up 28 projects that were approved. That was the first phase of the Rcgi that went from 28 to 29 projects really. And well, this is what we are reaching the 5 first years, which is now in November. So the idea is that the center will be supported for 10 years. And so we began in December 2015. This is an idea of our timeline. So the first phase started there when I said, and then a second phase started with the CO2 Abatement Program, which Giulio just presented in September 2017, and then the geophysics in 2018. And then we have new projects to come in December 2020. So that's the idea, that we are having this 5 years review where we are finishing some projects and going to the next phase for other projects. Here are the partners institutions, which you've seen in other presentations. So those partners that are within USP and others that are external. So there's national and international partners too, which I'll also go into that more in details later. So we have 5 programs, as you have noticed, 46 projects, and more than 380 researchers, which I'm going to give you a little bit more of information on that, which in this group, at least 42 of them are foreigners. So the idea of this research center is to have this multidisciplinarity for technical and scientific teams to work together. So it's a group formed by engineers from various specialties, from physics, chemists, lawyers, researchers in the field of history, geography, transportation, logistics, economics, mathematics, psychology, and others. Because the programs or the problems we are addressing are very complex and they are very interconnected. So it's interesting to have these people with different approaches working together. So we've got 28 university labs that are not only in USP, in our campus, but in many other places, and in Spain and in San Carlos, and even in international spaces. We've got international collaboration, which I will go in more details. And here's a summary of really what happened during these 5 years. Even though we are now about 380 people, we've already had 493 people that have passed through the Rcgi. That means there's students that have done part of their training and education with us, or there are professors or anything that have been with us together. So that's very interesting. 57 international partners, 37 national partners, and here's a bit of the production. 506 papers for conferences, 283 papers in journals, 19 books, 71 book chapters, the 28 labs I told you, the 139 events were held. Maybe we have much more than this, because a center with this size, sometimes it's difficult for us to get all the information central. So you will see a lot of the information was given by the programs. So you will notice that there's a lot of information over there, and we centralize all we can of this information so that you can have a broad view of what is Rcgi. We've got 3 patents, registered patents, and we received 4 awards in our research projects. Here's an idea of the profile of the people that take part in the Rcgi. You see that they are young people, like the people from 21 to 40 is the majority of what we have, even though we still have a group, a reasonable amount of people which we don't have any kind of identification or detailing. So you see how important it is for each participant to go into the system and put their information there, because that's the way that we will get the best information to give out for us and for who else may be interested in the center. Well, the positions, so you've got here the distribution and positions. Something very interesting is that we've got 30% women, even though we come from an area which is mainly normally occupied by men. So, but we are growing, and I'm going to tell you a bit about one of the programs that we took part in, which is helping also to bring more women into the area. Well, you also will notice that we've got people that are from different origins from Brazil. So we've got this representation of several states of the country, and also the international foreign people. Here's an idea of the participants by affiliation. So meaning we've got a lot of people from the Polytechnical School, but we also have from the Institute of Energy and Environment, and from IPEM, and from the Chemical Institute, also from UFABC, which is not USP. So you see here also a lot of this diversity, but we still have 78, which we don't have the identification yet. So seems that we have to still go into numbers, which is very interesting. Well, to give an idea of HR leadership and the administrative support, really we work as a process. So we work together, meaning that the human resources has been working with recruiting and selection, compensation, which making rules for this kind of compensation so that everybody is treated the same. And, you know, you've got justice and this kind of situation, which is the best way to be treated. Job descriptions, where it's defined what is specified in each role. With KPI indicators we are starting to talk about, which we are implementing, and training, development, and coaching, which can be in group, which can be individual. So this is something that happens on the ongoing. I come from a coaching background, so this kind of thing happens on the day-to-day whenever is necessary to deal with a conflict, to help somebody to think about something like a developing in their own area. So this is very interesting. And this goes also into the administrative support, which gets all this to support so that people can be concentrated in doing their research. So they take care of the scholarships and fellowships, the contracting services, the purchase of equipments and supplies, any kind of enrollment and participation on conferences and travel expenses. So to give an idea of recruiting and selection, these are the main ways of announcing, national and international. So we use our social media, so we use FAPESP and Poly, and we use other international partners here. It's an idea of how this is. We do everything inside our site, so it's very easy for the people to approach, and you've got the application form over there. So this gives you an idea of what kind of positions we had. And so with these positions, the person can apply, and when he opens it, he can have the complete information of what that project is related to, so that he can decide if he wants to participate in this or not. So that's the way we bring people in. This is an idea of how many positions we really announced and how many applicants we had for this, applications really. So 134 positions and 890 applications. And you can see a number of applications like for the postdocs, this is very intense, like 9 people at least for each position. But there's some that are 30, there are some that are much less, depending on the specialty. Much more foreign applications than Brazilian. Also here gives you an idea of where these applications come from. A lot of people from India, from Iran, Pakistan, Colombia, and then from Europe and Africa. Well, the idea was with then in human resources, getting a professional perspective in recruiting and selection, getting an interview process based on competencies. What does that mean? That you're not only looking at a curriculum, you also are looking at what is the profile, how does this person work, how does he work in a team, is this person capable of developing other people, of leading research, and this kind of situation. So I work in partnership with the the professors, for us to get the best people. So even though they have people that already are identified, we also put the announcement out so that they can have an idea of other people in the market, and also have always people prepared in the pipeline so that we can bring them easily if necessary. We've got an onboarding process, so that means anybody joining the center, we go through an onboarding process, and we've got the development process with courses, workshops, and coaching, as I've already mentioned, but mainly building the sense of belonging to the center. This is our software, which was built with a lot of help from Shell, with Camila Brandão. She did it personally, and thank you very much for that, because it's been very helpful. And we are working now to get it even better so that we can refine all this kind of information that I showed you. Here's the idea of the international academic collaborations. There are many, many, many. Here's only a few of them, because each project might have different situations. So UK and Europe with many, and United States, and also diverse, like with Queensland, like with Iran, or even though in UNES. Here are the ongoing research collaborations, which I'm not going to go in detail, but what's interesting about this is there are other lines, there are calls, there are open calls where the Rcgi did participate, and with their competence, they won the opportunity to get an extra grant for a specific project that is being developed in partnership with other universities or other partners internationally. This gives you an idea of where we are reaching out to international collaboration. And also with this kind of situation, just to complement what Gustavo was mentioning, here are many of the things that are done, and we work a lot in partnership, you know, so we work a lot in team. So here I'm going to mention two. There are two workshops that we held. One is this one on the right that you can see here, a group of women that the center was responsible to together with the international group for launching the Latin America branch for Global Women Network for Energy Transition. This was done in 2018, and the idea is women coaching other women to bring them into the area of energy. This was very interesting, and another, which I can say also happened here with the pandemic, was this one is written in Portuguese, but it's mental health, and it was the idea of talking to people about mental health during the pandemics. But we are going on with this talk also after. We already had two events with this, and talking about protocols also to resume back to work in safety. So this is an idea of people that are, you know, a lot of this comes from the initiative of the people that work in the Rcgi, and we try to make this happen in the best way. So, and there's many, many things that take place. Well, the idea is that we are contributing to the Sustainable Development Goals, which I'm not going to mention very much now because we're going to have a specific event that happens this month, and you soon will receive the information. But in any case, we are contributing directly with our projects with providing and ensuring cleaner and affordable energy, as well as taking care of the climate change, mitigating greenhouse gases, and spillovers and other indirect contributions with many, many others. But I'm going to keep you curious so that you can join us later this month for us to talk a little more about it. Thank you very much.
Thank you, Karen. Thank you very much for your presentation. And thank you all for following us and staying with us that long. It's been a long afternoon already. And we're having time for a break now. And then we're coming back soon after the break. I'll just show you what's coming next. So just remind about our program for today. We are about 15 to 20 minutes behind schedule, but we're having a 10-minute break now. And we're resuming at 5:05. Okay, so in 10 minutes time, at 5:05 p.m., we're coming back Then Alexandre Breda will present his perspective from Shell, and then all the participants will join in for a panel of discussions. Okay, so let's have a break, grab a cup of coffee. Thank you, Karen, again, and I see
Thank you very much.
in 10 minutes. Okay, see you all in 10
Okay.
minutes. Bye-bye.
Bye.
Hello, welcome back to the Rcgi in Review 2020. I hope you had time to have a break, to get a coffee and have a comfort break, because now we're going to our second phase of this review. We're going for a discussion, but before we start discussing challenges and the next steps, we would like to hear the perspectives from Shell. And today we are happy to have here Alexandre Breda, who is the Shell representative in the Rcgi, and Breda is he's agreed to give us his personal opinion, but also to speak on behalf of Shell on the development of the center in the last 5 years. Alexandre, thank you for joining us. We are ready to hear your comments.
Hi, everyone. Thanks, Gustavo and Julio, for the invitation for being here today. It's a pleasure. I hope everybody's doing okay, despite of this current extraordinary scenario. Yeah. I think COVID brings us a tough time in all aspects of life. Yeah. So for families, professional, and in our relationship. But I really hope that you are doing okay. Yeah. So I'm Alexandre Breda. I'm a mechanical engineer as a background. Currently, I'm the CO2 Abatement Program lead in Shell, Brazil. And I'm responsible for the relationship with Rcgi. Okay. Today we are here to celebrate a big, very important milestone for Rcgi. Yeah, and not only for the Rcgi, but I think for the research landscape in Brazil. Yeah. And I would like to go through 3 topics here very briefly. Yeah. First, I would like to bring a bit of history about Rcgi. Okay. Then, secondly, would go for some achievements, and then finally one special recognition that I'd like to give. Okay. So starting with some history, my personal history with Rcgi goes back to 2012, okay, when FAPESP and BG hold an international workshop to define the topics that would be part of the call for proposal, aiming the establishment of the center, the Gas Innovation Center at that time. Okay, and at that time I was working for Congas, that was still a BG company, and joined these 2 days with very fruitful discussions. Yeah, and after that I moved then to BG, and then I had the pleasure to lead the call for proposal properly. Yeah, and for the establishment of the center, and went through all the evaluation of the proposals, and then for the contracting of this winning proposal that was led by Professor Julio, yeah, and hosted by the University of São Paulo, as you know. We signed the contract on December 2015, yeah. And I think since then, it's amazing seeing the evolution of the center, yeah. I think we started from a paper, from an idea, and now we have a very vibrant environment where circa 400 researchers try to do their best in the topics that they represent. Yeah, and also we have the admin staff, always available, very, very helpful and professional. And it's really a differential that the Rcgi brings, I think, to the research landscape in São Paulo, with this strong internal support in all these different areas, like I think Karin shared before. Yeah. And then I became a Shell employee after the combination of the 2 companies. So as you can see, I went through 3 different organizations, Congas, BG, and Shell, but always involved with Rcgi. Yeah. We then brought more projects and different challenges to the center that embraced it and started the adventure of decarbonization of the society. Okay. I think after now these 8 years of my relationship with Rcgi, I can loudly say how grateful I am with the results obtained and with the people involved. Yeah. And I'm sure and confident that with the people we have, we will go much further and higher with the center. Yeah. We have here more than, as Karin presented, 280 papers in journals, more than 500 conference proceedings, 19 books, 3 patents still pending to be granted, but 3 patents submitted, hundreds of media quotes. Yeah. We have also an ANP award from last year for the South Cavern project. We hosted in Rcgi the Dutch and the British ambassadors, Her Honor UK's Minister of Finance, and this was just the initial 5 years of the center. It's just beginning. Okay? And we are more than 400 people that are looking for making the difference. Okay? I would also like to take this time to say a big thank you to Professor Julio. Yeah. Julio, your passion, your charisma, your leadership, your energetic enthusiasm make the difference. You have a strong entrepreneurial and scientific mindset. And this is not trivial, this is not common. This is one of the great differentials we have in your center. Yeah. Thank you very much and congratulations for everything that you have achieved so far. Take also time to celebrate. Yeah. I think the topics that Rcgi is covering is pretty aligned with what is needed by the society to achieve the Paris Agreement. I think we have built the foundation in the center, and proud is what defines my feeling today, yeah, after seeing these results in a glance. I think we have the correct challenges, that is our purpose. Yeah, we have the right people, we have resources, and we have the proper landscape. And now I think it's time for the next step, for being more ambitious, targeting real deployment of the technologies we are maturing towards real innovation. I would like to bring here as an initial example, the project number 9, led by Professor Guardani, has just submitted to another funding the demonstration of the LiDAR technology in a real offshore environment. I think this is the first of a series of real deployment that we are targeting for the upcoming future. Real and tangible innovation for the society. Okay? I think said that, a brief history, the achievements, the recognition, and wishing you all a pleasant evening and rest of the week. Stay with us for the next 5 years, yeah? And stay safe, stay healthy, and please join us for the discussion now with Gustavo and Julio and Bruno and Karin. Please, Gustavo, hand over to you. I think you are on mute, Gustavo.
Thank you, Mr. Chairman. I thank you for your very nice comments, and I appreciate your also very passionate review of these 5 years. And I have quoted you here. We have the people, we have the resources, and now we have the proper landscape. So I think that was very good to hear from your perspective. Thank you very, very much for that. I think now we're ready for some more discussions on these topics. And as we did yesterday, we would like to invite you all who are watching to not just watch, but to participate in this discussion. Just type in your questions and suggest topics for discussion down here in the live chat. And we will be able to interact with you and with all the speakers through your comments, okay? We're moving now to the last part of our meeting today, and I am inviting now all the speakers of the day, Karen, Julio, Bruno, and Alexandre. I think we're all here now, yeah? Good. And if you have then questions, please do send them in, all right? I would like to start with Julio. Julio, maybe you would like to make any comments after Alexandre presented his perspective, so we can start the discussion?
Yes, well, just few comments. As Alexandre just mentioned, it's a very long history, Alexandre. Yeah, I remember the first time when you came to NDF to discuss the ideas that you were planning with John Costin at that time, and you together with him were planning the creation of a center. And that was an idea that I was really attracted. And then as you mentioned, well, the question of leadership, you are a person at Shell, well, through Shell now and before with Comgás and then with BG before Shell nowadays, you were able to, how can I say, to show some challenge that could, as I said yesterday, conquer minds and hearts. And I think that was important since the beginning. And your support was really very important at that time. And nowadays, wow, I have to say that your support is the most important part for Rcgi, because you give us always the means to do what we believe that's important, not only for research, but well, for the development and now for climate change and the new reshape of Rcgi next year. I think that most of the people, I would say all of the people at Rcgi, is really very well motivated, and you are one of the reasons, because you brought all those challenges to us and they are supporting us through Shell. And then thank you very much, Alexandre and Shell people and all the rest of the team, because we are only part of that team. And those who are working from the scientific initiation people towards the MSc students and PhD students and the postdocs, those are the soul of Rcgi that make things happen. And then thank you all. And these are the only comments that I'd like to say now. And then Gustavo, please.
Thank you, Julio. Thank you. Well, maybe we could start discussing the goal of the Rcgi and how we structure our research and how this should be considered for the future, especially phase 3, that is beginning next year. We all know that we are in search of disruptive technologies, disruptive research, something that changes the way things are done. This is an ultimate goal of long-term research on technological topics like this. But we also are aware that in this process of searching for disruptive technology, we may get some quick wins. And this has been a language that we have been accustomed to use from the beginning. Disruptive research in the long run with some quick wins in the process. How do you see, Alexandre, Julio, and Bruno and Karen, this dual attractor, so this dual direction that we follow with disruptive research and quick wins in between, and how can we prepare ourselves and our research projects to actually contribute in both directions? Or should we contribute in both directions? Or should we just aim for disruptive research? Or should we just aim at the quick wins in the long or in the short-term results? What are your views on that?
If I may, Gustavo, sorry for the others. Sometimes we want the 100%, yeah, and then we have already 80% sure of something, yeah. I think in the startup environment they use a lot the MVPs, the minimum viable product, yeah. So when they had something that seems interesting, it's ready to go to the market, yeah. They know that they have failed, yeah. And this is why we receive so many updates from Google, from Apple, in our iPhone, in our mobiles, yeah. When they have something that is good enough, it's already in the market. Don't need to wait until the 100% certainty. First, because the world change, and the 100% certainty today will not be tomorrow, yeah. And the other, that 100% certainty will never be there, yeah. So perhaps we need to change the mindset a bit, yeah. Instead of targeting this 100% certainty, we can try to bring to the stakeholders, to the society, some minimum viable product, yeah. And this can be the quick win, yes. If the quick can be 1 year, the quick can be 5 years, yeah. The quick is also not an absolute service, yeah.
Absolutely, yeah.
But I think I think we are working with you, with Julio and others for the innovation landscape, for the future of Rcgi. And I think the LiDAR that I brought here is the first example, but I think we will have others to share in the upcoming future. And to really bring to the society this fantastic scientific work that you are doing. Yeah, I think so many fantastic achievements, and how to that famous valley of death, yeah, for technology, how to overcome it, yeah, how to make a bridge, yeah, and of course the university makes a fantastic job until a technology readiness level around 4 or so, yeah, and others need to take it over to go to mature this technology, yeah, and it's not necessarily in the university. It's a startup, it's with big companies, is with suppliers. So I think this is what we are going to build now with your help, your support, you leading this actually, yeah, on how to make this bridge, yeah, bringing this scientific knowledge to an innovation, yeah.
Right, thank you. Anyone would like to comment on that? I'll just put some, Edmilson sent here, Shell has an action for startups. Can these applications be supported by this action? I mean, there's a question before that I have to show before that. So how companies in general and Shell in particular can still contribute towards material applications of technologies developed or underdeveloped by the RCGI?
Again, I think, Edmilson, if we take, I think, this area of energy transition, there's a lot of money available for this area. Yeah, I think we are hearing in the media several big companies putting big money to demonstrate and to mature technologies. Yeah, I think we need somehow to try to access also these other funds. Yeah, it's not only about Shell, and this is the sustainability also of the center. Yeah, I think is the FAPESP targeting this. We are targeting this as well. Yeah, we want to see others also investing in the center, and this is this maturation of technology. This one that we applied, the project 9 submitted, applied, is not for Shell. It's for another fund. Yeah, I think we have now in Brazil, even in Brazil here, the Prosperity Fund from the British government. They have some budget available also for demonstration of technologies. I think you have seen Microsoft has issued also a fund for climate-related technologies. But I think there are several other funds, and I think we are now with some solid results from the existing projects. We are able, the RCGI is now able to show to this other funding what we have to mature further. Yeah, I think now after these 5 years, after this scientific development, we are in a good shape to look for other opportunities for maturation. Yeah, and this is the area that we are working. I think money is there. Yeah, I think I have a friend that always says, this is not a problem of money, it's a problem of ideas. Okay, there are more money than ideas. Okay.
Right, thank you. Anyone would like to contribute? Julio, yeah.
Well, as Alexandre said, there are some other fundings. We are already working on that together with Gustavo and Carolina from Shell. We are setting up together with Alexandre, of course, and then we are setting some new routes to pass through that valley of death, as Alexandre just mentioned. But it's interesting, I was thinking the model, it's essentially the triple helix model that our center and FAPESP through the CPEs, the Engineering Research Centers, ERCs in English, or CPEs in Portuguese. This is, I think, that's, the ideal model. There is no ideal model, but this is the model that that makes things most efficient. And what I mean by that, if you take the TRL, the technical readiness level, we can have in our center things that goes from 1 to 6. Those that are above 3 and 4 should go towards some kind of, should go towards spin-offs and startups companies. But it's just in a center like ours that you have the, how can I say, the critical mass of brains to have projects that are still with a low TRL, and those who are closing to the, they are close to the valley of death. And it's just with a center like ours that has the sponsorship from the state towards FAPESP, the sponsorship from Shell, and the sponsorship from the university, in our case, USP. And then I think that this is the model that makes things being optimized. And I'm, how can I say, through defender and, how can I say, a believer in such model.
Thank you, Julio. Anyone else would like to comment?
Yes, I'd like to comment. Something very interesting in the center is because this model, this open innovation model of the triple helix, is something that that we are becoming to know it even more. And in Brazil, it's becoming more important. It's already evolved in other countries. And something interesting is that we are able to study this inside the center. So this is one of the areas which I've been working on. Just wrote 2 papers on that. And, you know, really studying this, it's how it is important for you to work with the 3 together. You know, the university needs the company, and the company needs the university, and the support that comes from the funding agency is also very important. So really, that's what makes an ecosystem work, and an ecosystem of innovation, because you take some time until this starts, really. So I think it's a very good point that Alexandre said, that we take the first 5 years really developing a lot of this technology and the understanding and even the way of working together. And now I feel that we will get into another phase, really more mature, where the kind of sending these kind of technologies or putting them through to the market will be very important. So yeah, it will be very important your role, Gustavo, doing that for moving it forward.
Thank you. Bruno, you would like to say something? Yep.
Yeah, I would like to make a comment, something that's not exactly what you are commenting about, but something related. It's about people. I think most of the time we're concerned about the technologies that we develop inside the center, how it could make its way to the market and become something that's useful for the society. But I guess one thing that I think it should be good if you pay more attention is about the people that we have inside the center. Most of the people that we have there they are not professors, they are students, graduate students, postdocs. So they are supposed to be in the center for a short time, okay? They are going to leave. And so where do they go after that, okay? I think that's one of the main questions that we should face for the next, this phase, okay? So these people will carry an experience and ideas that should make them valuable for the market. Okay, so besides developing technology for the society, we should be developing people for the society. A new working force which has been educated, maybe educated is not the proper word, but trained in technologies that are relevant for the future. And I think, in my opinion, that's one of the main challenges that we have now. Okay, we've been successfully developing technologies. We have the salt cavern, we have the LiDAR, as Alexandre said, many nice ideas. But maybe these people that we are training, they are not encountering the right place for working after they leave. Okay, so maybe our talk with the companies nowadays should also include this aspect. Okay, we have very competent and able people in our center that are finishing their PhDs, their postdocs, their MSCs, and they should be able to find a place after that phase where they could develop all the potential that they have. Okay, so I think besides the technology, besides the knowledge, we should also think about the people for the next phase of the Rcgi.
Thanks, Bruno. That's indeed very relevant. And do you want to proceed?
Can I comment on that?
Sure, yep.
Well, thank you very much for you mentioning that, Bruno, and you also, Alexandre, because people are very important. If you don't have the right people or go ahead with these people, you won't have any technology really done. One of the things that I started to do was I had a first meeting with the postdocs, which they will have a career for some time with us and probably go to other parts. So we started working together to identify ways in which they could develop while they were in the center, and they could develop even further. So they settled groups within themselves, and they started doing that. One of these groups was one of these initiatives was the one that's working with the mental health, and also with having secure protocols for working inside the labs and inside our installations, for instance. There are people that are interested in starting to teach, really. So we got closer to other kinds of that they are not positioned really as a professor, but they can take part as in those programs that are offered to the market, for instance. So there are many things that can take place. And well, we had only one meeting, and that was it only started with people working with other people. Then unfortunately, I'm not in Brazil, so that's something that made it a bit more difficult. But I know they go ahead with doing that, and we should stimulate this to go further in all the levels, which is very, very important. And related to that, we have to work also with the diversity and inclusion, which is part of already what the university does when they have these kind of quotes for people to get into the university, but we can do better inside our center. So this is also something we aim to do to bring more people. And I think that something that we're working on also is the Sustainable Development Goals, which in one of them is very important, the side of inclusion and having an environment where people feel safe and justice and growth. So this kind of thing will become more and more important.
Okay. Since you mentioned that, Karen, let me move on to another topic. And perhaps we could answer specific questions in the chat later on as well. But one, we have agreed now that it's not just doing good research, but is to promote an impact, actually to have an impact in changing something and changing society and pushing the boundaries of knowledge and transformation further out. And we all know that climate change is a topic coming up. It's already there, but it's coming up as could be thought of as the new pandemic or the new tragedy we were expecting to deal with in the future. But Alberto Fossa asked here how we, Rcgi, can make a difference in climate change, and especially with the Sustainable Development Goals that are one way to actually identify areas to develop, actually to promote development in the world. How can we project our projects and results in this language or in these fields that are necessary to be tackled, but also keeping in mind climate change. Any views on that?
Again, if I may talk about the climate change
Sure.
a bit.
Yeah, go on.
Again. Fossa, obrigado. Thank you, sorry. What I think, there's no silver bullet for the climate change. Yeah. So the challenge is extremely huge. Yeah. I think society is aiming for a well below 2 degrees or 1.5 degrees by end of the century. We need to achieve as a neutral carbon economy by, depends on the scenario, 2050, 2060, 2070. Doesn't matter. It's a matter that is really challenging, yeah, to achieve that. So, and also to address this will be different from countries to countries. Yeah. In our case here in Brazil, our energy matrix is already quite clean. Yeah. What can we do different? Yeah. If you take the projects that we have in Rcgi, we are addressing several issues. Yeah. Again, are we going to solve the problem of the world? No, far from that. Yeah. But I think each one of us, each one of the different centers that we have in the world addressing the climate change issues in technological areas, in advocacy areas, in different sectors. Yeah, everybody has a role to play, and I think in our case, let's pick up just one example here, but the labyrinth seal one. Yeah, this is a very practical one. Yeah, so if we could decrease the fugitive emissions from rotating equipment, is a huge step forward. Yeah, again, very important. It's another good brick in the wall. Yeah, but how many bricks will be needed? We have 35 gigatons of bricks. Yeah, this is the total GHG emission. Yeah, so this is another brick. Yeah, so I think we can put several bricks in this wall. Yeah, and can make more sense in Brazil, can make more sense in other countries, but I think we have a very important role to play here in Rcgi, and the results that we have achieved so far are confirming this hypothesis. Yeah.
Good, thank you. Anyone else? Yeah, go on, Julio.
Yeah, thank you, Alberto, for the question, because I will be even more direct than Alexandre. How Rcgi can collaborate? Well, perhaps creating 5 new programs, one that we will work on nature-based solutions, another one in carbon capture and utilization, another one in bioenergy, carbon capture and storage, another one in greenhouse gases, and finally one in advocacy. And if everybody at Rcgi works in a complementary way, and there is, of course, there are a lot of intersections in terms of knowledge, of course, but if you work with social perception together with, let me see, carbon capture and utilization, and if you work towards the goal that we have to focus on how to keep that target of temperature rise below 1.5 Celsius and towards the neutral society, I'm sure that having a multidisciplinary group, the ideas and the small bricks, as Alexandre just used the analogy, of course, there will be many new bricks that will sum up and will give solutions, and one of them is what Alexandre mentioned, the labyrinth seal. Another one the LiDAR that now is going towards a new kind of sponsorship, and others that will come to produce green hydrogen and so on. These are the kind of solutions that only with a center like ours, we have people working in a synergetic way and with synergy, and can come up with those solutions. And then I believe that the answer, well, one of the answers is towards centers that have this common goal, and this is my answer to Foss's question.
Thank you, Julio. Anyone else would like to comment on that? Yeah, Bruno, go on.
Yeah, I guess we're in a strong position to make this relevant for the academic environment as a whole, because we are a very large center. Okay, we have 400, more than 400 researchers working in projects related to the Rcgi, and those researchers are not only for projects in the Rcgi, but also to something else. So if we manage to put this the relevance of the sustainable development goals inside the culture of the Rcgi, I think we're going to make a very strong contribution for that concept to permeate the academic environment, and also contributes to the other areas and other researchers to also think about that. Okay, so I guess that's a very nice way of thinking about the responsibility that you have with your work in general and with your research in particular. And if you could make this a strong aspect of the culture inside the Rcgi, I think that's a very nice contribution towards this goal. As Julio said, all the projects in the phase 3 of the Rcgi are very related to the sustainable goals. So I think in terms of direction, we are already there in terms of other future projects, but it could also make a contribution to try to make that go into fashion, let's put it like that, for the academic works. Okay.
It's interesting, Bruno, that sorry, Karen, let me just put something here.
Go ahead.
It's interesting that the SDG, Sustainable Development Goals language, is already immersed inside the university and the academia and some other spheres like science and technology. But it's becoming more and more aware to the open public, right? We have seen recently, actually on television, on open television, that image of the colors of the goals being announced. And I've seen this just this week, and I was surprised to see that language now being openly spoken of. And so we are working towards those goals. We are achieving technological solutions in that direction, but there's also the perception that society and the public in general will have on us achieving those goals. So what does it mean to work in that direction? So that's what we call the big thing as public perception of climate change, or public perception of the technologies fighting climate change, or public perception of that. So how does the public perceive or sees what we are doing, and how does it change people's lives and the way they think? And somewhat related to what Bruno said, creating a culture, not just an academic and scientific culture, which I think it's going that direction anyway, but also a wider general culture in the society that has to listen or to be influenced by academia and scientific knowledge in order to gradually move in that direction. We are in a time that a lot of science is being reduced and actually being denied, and this kind of negationism. We've seen this recently many times happening, and there's something that will always be there. And in climate change, there are negationists as well. And how can we as a center, in between industry and academia, with so many stakeholders and people interested in the topic, how can we improve the public perception of this topic, of these goals, and also of the results that we might achieve and contribute towards those goals. Would you like to comment on that?
Yes, I would like to comment. And very well, what Bruno did really has to become something that people talk about, that people are conscious about, that they are knowledgeable about. And well, in the Rcgi, we started talking about this maybe 2017, 2018, when Oscar Serrati was with us, which he had experience with the UN, that was with the United Nations. That was very, very good because it was an opportunity for us to learn. And so a small group of people got together with him and we learned a lot very quickly. And then we started thinking about this and to propose this as a project, which I presented there in name of the group in one of our sessions, in one of the conferences. So the idea was really to make people think about this. But as you see, this takes time so that it can be matured even inside our center. So this was in 2018, we talked about that. Really for the first time, bringing out an opportunity to really work focusing on it. And now for the next year, so for 2021, we are going to work in a project focus on that. So really making people understand what it means internally and externally. So I think this as everything that happens, it evolves with time, you know. And if people are really moving this forward, like we started talking about that, we talked about it in 2018. Then we talked about it again in all kinds of opportunities. And a group got together and started studying it. For instance, now a group of students together with Drieli and myself, we've been talking about this, and this became a report which we're going to launch now in October. When we looked at the SDGs within the center and what kind of contribution do the projects have to the SDGs. But really, this is important, but we need to speak to the people about it. So, for instance, this last one, we used a questionnaire where 40% of the people didn't know about the SDGs. So they hadn't heard about it. And 60% said they heard about it, which doesn't mean they know exactly what it means. So there's a lot of work we have to do, really, in the internal public perception and the external public perception, too, with the SDGs and with the technologies we are going to work. So I think that's very interesting because Shell has this kind of understanding. So we never had any problem in trying to study anything that was social or that wasn't not specifically technical. We never had anybody saying, no, you can't do that. So we are trying to move this ahead. And I'm very, very happy that you are all involved with this too.
Thank you, Karen. Anyone else would like to comment on that?
Yeah, I'd like to add quickly. Are you hearing me?
Yes.
Yeah.
I pressed the wrong button here, sorry. Yeah, so I think in terms of public perception it's all about communication, you know. Yeah. I think in the previous years, I don't know what happened, but I don't know if the scientific community didn't communicate properly with the society, but things very weird happen, like people talking about flattening Earth or doubting vaccination. So these really strange things grew in these past years. Yeah, how come? Yeah, this seems so unreal. Yeah, so it's even difficult to argument against these things because it's so obvious. Yeah, perhaps we are not communicating properly in the same language as our society needs. Yeah, sometimes we communicate in a very complicated way, and so as you mentioned in your presentation, Gustavo, there are several layers in this communication. Yeah, and communication is not what we say, but what the other understand. Yeah, and I think the others are not understanding very well what we are saying, yeah, and leading to these different conclusions, like that, okay, the Earth is flat, or the vaccination makes no sense. And so perhaps I think this is what is very important in this way forward for our center here. Yeah, and the role of the dissemination of knowledge also plays a key role. How to communicate properly, yeah. And not only, okay, I gave a paper to the conference, okay, but who can read that paper? Yeah, only you guys. Yeah, I can't as well. Yeah, so we need to translate somehow that amazing information into something more easy for consumption. Yeah, and I think this is the way to gather the support from the society. I think climate change now, at least people are not discussing if this is true or not. I think now, if we return to 10 years ago, were still some discussions, okay, if climate change was real or not. I think this is not a point of discussion anymore. Yeah, but the technologies needed to overcome this issue, I think this is something that we need to be pragmatic, proactive, and very clear in the communication we give. Yeah. That's
Thank you, Shanti. Yeah. Yeah, I think the strength of a center like this, which is very multidisciplinary in its projects, has a broad portfolio of projects and ideas that change with time. So if you just see from the last 5 years, we had 3 calls for projects in our center. So phase 1, phase 2, phase 3 plus geophysics, and they all had different a different focus or different aspects in the topics of the projects. So it's natural that the interest and the research will be dragged to some direction or the other. But that is natural because that follows what needs to be developed, but also what society wants to see developed. But now, using this multidisciplinarity aspect, we should, as academia, so we are academia in the sense that we are a voice in the society with the capability of not just discovering new knowledge or unleashing new knowledge, but also with the capability of influencing new minds. So the next generation of professionals are passing through our classrooms right now. So we are in this privilege, but also a position full of responsibility, that we are not just working to help a company, but we are also taking that knowledge and development and transferring that, imprinting that into the minds of the next generation. So I personally believe that's one of the biggest motivations for being in academia, for being a lecturer, a faculty member in my life. But now, I think you said something very precious, and that's very important. The way we communicate those things is not just putting the information out there. It's not just saying something. And I would say it's not just making sure that people heard or listened to what you said and understood, but it's communicating in a way that promotes change, and promotes change in a good way, not to be not to promote change just because you think that it is correct, your viewpoint is correct. No, but to give information so that good change will be naturally developed in the society. And that is the pure definition of culture, how you cultivate something and you cultivate some knowledge into the society. So if the topic is climate change, how can we contribute as a center with the voice of academia, with the tools of science, then to imprint and generate culturally a transition or a transformation towards that direction? And identifying this role and also accepting this role and finding the tools and mechanisms to do that, I think is very important for a center. And we were not able to do that alone. We're not able to do that in departments, in our universities. And I don't believe we are able to do that in faculties. I think we're able to do that in centers because of the multidisciplinarity of the center and the proximity with industry, with government, with funding agencies, and with the voice that represents to the society in general. So I see a very strong reason for the RCGI to exist, being a voice of transformation in the society. We are only 5 years old now, but I hope that in 10, 15 years, 20 years time, our voice will be heard and will actually generate some influence and cultural change in the society. But for that to happen, we have to keep that in mind and to actively work in that direction. So that's my my view on that. But I have to stop talking and let the final topic for discussion to appear. And I would suggest here that we talk a bit about international collaborations. That was a topic that appeared yesterday, and I know all of us here have been influenced from very good international partners in the past. And I would like to hear from you, what are the key aspects for a good and sound international collaboration? How can we identify a good partner? Because there are too many partners out there, and you cannot be a partner with everybody. It's very unfaithful, this type of relationship. If you are a partner with everybody, you are partnering no one in specific. So how do you choose your partners? How do you choose your international collaborators? And how do you bring them on board to help us be a voice in this transition, and not to be consumed or just to be side actors in their own interests and in their own projects abroad? Who would like to comment on international collaborations? Julio, yeah? I think Julio is the most international of all of us. He's traveled more miles than the president of American Airlines. And maybe Julio would like to comment. Yeah?
Well, that's not true, but anyway. Yeah. But, well, I would say that in the beginning of the center, well, before talking about international collaboration, regarding the SDGs, because there is a relationship between international collaborations and the SDGs. And then first, the SDGs. It's interesting, I just learned that the SDGs were announced 3 or 4 months before we started RCGI. And it was in September 2015. It was 4 months before the starting of RCGI. And then the SDGs are the framework for us to better communicate with the whole society, not only the Brazilian one, but the society around the world, and collaboration. In the beginning of the RCGI, one of the key points of a center like ours is to have a strong international collaboration. And then from the beginning, we had in the first 3 years a very intensive, how can I say, travel to some key institutions abroad. And then I think it will answer your first question. We have to find those institutions abroad which are leaders in their specific fields, or I can give many examples, as we started from the beginning with a strong collaboration with SGI, Sustainable Gas Institute, hosted at Imperial College. And then that was the first one. But then we mapped some other institutions that, of course, would include Europe, some countries in Europe that in terms of natural gas, hydrogen, biogas, energy in general, were leading institutions. I'm not going to list them because it would be unfair if I forget any of those that we visited. But United States as well, not only universities, but labs. Then we and there were always representatives from all the 3 original programs of Rcgi, then CO2 abatement as well. And then we mapped, well, Europe, United States, Australia, that, well, they have a strong program in CCS, some pilot projects that had a very long history. Well, Japan as well. And then the first 3 years we mapped it, and then we mapped it because we could collaborate. It would be not one-way collaboration, it would be two-way collaboration. A two-way collaboration, that's the best thing. And some of the collaborations that we started, even FAPESP came together with us. And it's interesting, the C2C collaboration, it was an initiative that started with Rcgi. Then FAPESP got interested. FAPESP, the scientific director of FAPESP, was contacted because, well, NSF was contacted by one of the center, and we contacted that center that through Emilio Neri Silva, who was collaborating with Engineering Research Center POITS, the first one that we are going probably to set a C2C collaboration soon with the sponsorship from FAPESP and NSF. And then this kind of mapping in academic, scientific, and innovation matters are fundamental, because it's through, how can I say, you have to think out of the box or out of your country, because climate change and energy are subjects that are not only concerned with São Paulo state, Brazil as a country, but the whole world as a whole. And then that was how international collaboration entered and is growing our international collaborations in a way that hopefully for the next phase will make other collaborations come through. Thank you, Gustavo.
Thanks, Julio. Thank you very much. Who would like to add to international collaborations? Bruno, yep, go on.
Thanks, Gustavo. Yeah, I think the Rcgi gave us a lot of opportunity to start new collaborations, to develop collaborations that we already had. And I also going to talk something based on other collaborations that I have outside the Rcgi. But I guess the Rcgi put us in a very good position because of the fame of the center. It's a very large center. Because of our partnership with Shell, it's something that's very valuable when we want to talk to someone abroad. Everybody knows Shell, okay? So if they get to know that you are sponsored by a company like Shell, it's already a very nice stamp in our business card. I guess I'm going to focus on the aspect that you said about how to choose the international collaborator, okay? I mean, there are many people we can talk to, and there are many people that will answer our emails and schedule a Skype talk. How do we choose who you're going to collaborate with? Okay, so I just drafted a quick list here. I think the first aspect is to have common goals, of course. That's the main, the starting point. You shouldn't go to a very nice university just because of its name, but you have to see if they work in something that you are also interested in. And the second aspect is you have to bear in mind that you connect with people, not with the institution, sure, yeah, and not even with the lab. Okay, you're gonna talk with another person on the other side. So you should focus on that character, okay? So if he or she is interested in what you are doing, if they reply to our emails, and if they have time to pursue a new direction with you. The third aspect that I think it's important to think about is to ask yourself, why should we work together? Why should I do this kind of this job with this other partner, and not do it alone by myself? Okay. So what does this collaboration bring to you? And on the other side, the same. Okay, what do I bring to the other partners? Because a true working collaboration shouldn't be just the sum of the two parts. It should be something new. Okay, that should originate something that couldn't be developed by themselves. Yeah. Yes. Okay, so that's makes it valuable, because people then will care about you working with them, and the same for you. And last but not least, I think developing a collaboration is like a date. Okay, so start talking, you schedule some meetings until you get to really something concrete. And I think that last step is maybe is the valley of death for the international collaboration. You have to identify people that really want to commit. Okay, in terms of working hours and budget. Okay, you have to be honest about that. I mean, you don't do nowadays. You don't do relevant research without any money. I mean, you have at least to pay the scholarship for your students, and even if you don't need lab equipment or anything, but you need a little bit of money for that. So, if the other side doesn't want to, pitching with at least working hours, then it's doomed. I mean, you shouldn't really developing into anything really significant. So I think those four aspects are something that you have to bear in mind when you are developing international collaboration, and even a national collaboration. I think it goes for any type of outer collaboration.
Good. Thank you for your analogies, Bruno. Became very clear. Okay. Anyone else would like to?
And I think this effort, just a quick one, this effort pays off. Yeah, I think there's a paper from Professor Brito. The papers with authors and co-authors in Brazil compared with papers with, I think the leading author is a Brazilian, with co-authors from abroad. Yeah. And the impact factors of those papers with co-authors from abroad, yeah, are the impact factor is much higher. Yeah. So there's data for this also. So I think I agree with you, Bruno. This is not easy, yeah, for this dating analogy, yeah. But I think the results are very concrete. Yeah.
Yeah, I'm sure of that. That's very, very good points, Alexandre. Those works are much more relevant. I mean, just the indication that the work were carried out by two different institutions, that's already an indication that this is relevant for a broader audience. Okay, so departing from that, you already have a good evidence that this will make a huge, a higher impact.
But this point that, Alexandre just mentioned the paper and that Carlos Brito wrote, and it's interesting is that is valid in the other way around as well. It increases the impact of the citations on the Brazilian side, but also for those who are abroad. And then it goes towards what Bruno just mentioned, that is a two-way effect that is extremely important. For them, it increases also the impact of the papers when there are co-authors from Brazilian universities, in the same way that happens for us.
Indeed. Well, thank you. Thank you all for your comments. I think we are very clear that international collaborations are important. It's something that we have to take good care of. just like our marriage. So just to use the same analogy here. So we've dated, now we got married, and now it's time to take care of that marriage. So we're going to see our kids growing up in the future, right? So thank you all for those comments. And I think we came to an end. This is the end of our discussion today. We are preparing more of this online event, of course, since we cannot get together due to the pandemic. We'll try to have more events like this. So you should expect to see other events in the Rcgi YouTube channel and also on our website and Facebook page being announced in the next weeks and months. So please subscribe to the channel, send us your email if you have not yet registered for this event. That was just a way for us to get your contact so you can receive information about the next Rcgi events and videos and interviews. Okay. I think we have had very good 2 days of discussions and presentations. And before we say goodbye, I would like to ask if any of the panelists would like to say a final word, just to say goodbye, or to raise any final point before we say goodbye. I will start asking here. Bruno would like to say something?
No, just to say that it was a pleasure to have this online event. I think that's a new experience for all of us.
Good.
I think you, Gustavo, are more accustomed to that, but for me, it was something new to participate in a panel like that, and I think it was very fruitful. So thank you very much, and thank you for all the audience that was logged in.
Thank you, Bruno. Thank you. Karen, would you like to say something before we go?
Yes, thank you. Well, really made me very happy to be in such wonderful company, really, because seeing the group that is managing this center is involved with very important aspects, not only the technology side, which is very important, but also the social, the perception, the SDGs, and all this kind of thing, which make great difference. So I'm very happy to be part of this group, and very honored to be working with you together.
Thank you, Karen, for your availability. It's already 10-11 p.m. in London. Alexandre, would you like to say your final words?
Yeah, thank you, Gustavo, for leading us today, and thank you for everybody that stayed with us until now. I think just to reemphasize, yeah, again, we have the purposeful challenges here. We have the right people, we have resources, and we have the proper landscape. Yeah, so let's make the future. Thank you.
Good.
Thank you, everybody.
Thank you. Thank you very much, Alexandre. And now we finish with Julio, who is the Rcgi Scientific Director, and his final words.
Well, thank you very much, Gustavo, for organizing this event in this new format. I enjoyed very much these 2 days, these 2 afternoons here in Brazil. And well, thank you all, those who are part of Rcgi, those who are going to be part of the Rcgi very soon. And it has been a great pleasure to be part of this team. And part of this team because, well, as Alexandre just said, well, we have to try to make the future and try to make it better, a better future and a better world. And now that we are going to get more and more involved with climate change, we have the opportunity to make things happen. And then for those who were working with us, and for those who are going to continue, and for those who are coming to work with us, are very welcome. And let's start our new phase in our new 5 years, the 5 new years, the 5 years to come. And thank you all. Thank you very much.
Okay, so thank you all for staying with us. Thank you all the speakers of today and yesterday. and we are glad to conclude now the Rcgi in review, 5 years of gas innovation. We hope to see you again for the next review and for the other events of the Rcgi. Have a good evening and have a good happy hour if you wish. Bye-bye.